Today I'm going to discuss about pre-trained model. Okay. So what is pre-trained model? So I took some slides from the Harvard lecture notes. And what I'm going to discuss, there are three things. Okay. The first is what is pre-trained model. And then we are going to look the details about BERT, what is BERT. And we are going to look more details about GPT. And at the end, let's do the code analysis. What is the code for these two? This is one of the good books related to pre-trained model. Sometimes people mention the pre-trained model is the foundation models. In this book, they discuss a lot of things about the foundation models for the natural language processing. However, this book is more focused on the media, So yeah, if you have interest to read the book, you can refer to this reference. So what is pre-trained model? If we look at the foundations of the pre-trained models, we have pre-trained. It means we already trained with some data. The main idea behind pre-training, pre means before. Main idea is to transfer knowledge from an already trained model. And it comes in many forms. For example, the one that we learned before the mid exam, it was the word to fact. Okay. Word to fact is one of the pre-trained word embeddings. This kind of pre-trained word embedding, we have a fixed embedding matrix. So the size always same. We can also use another kind of pre-trained model, for example, ImageNet. This ImageNet, usually it is good for the image data, or we have the figure. The pre-trained feature extraction layers, and the final layers fine-tunable. So at the end of the layer, or at the end of the neural network, we will do the fine-tune. There's also another kind of pre-train, like inversion. They use the RNN encoder for the sentences. It is fixed model, and the pre-training done on supervised tasks NLI. So this is natural language inference. And there are another kind of pre-trained model, we call it ELMO. So today we are going to look at also the detail. It is the pre-trained model for contextual word embedding. Contextual means, yeah, it is based on the context. If the context is about news, then it will be about news. If the context is about movie, then yeah, there are also some embeddings about movie. Use as it is or fine-tune linear layers on top. So all those things are related to the fine-tune. For the fine-tune, next week I will discuss more the basic fine-tuning, how to leverage the fine-tuning, especially when we have the pre-trained model. The evaluation of pre-trained models, if you already learned the early embeddings, like the word to fact, or I explained to you about GloVe, and I also explained to you about fast text before the mid exam. Yeah, those things are the early stages of the pre-trained model. But after 2013, 2014, people developed a lot of other pre-trained model like fast text, inverse, and in 2018 it becomes more relevant for us, which is BERT, and also the GPT, and so on. So now, people develop a lot of kind of pre-trained model, such as the GPT. What is GPT? So we're going to look at the details. After 2019, after 2018, so we learn about the transformer. The last week we learned about the transformer. What is transformer? And after transformer, many people use the transformer and develop the pre-trained model or the advanced pre-trained model, such as BERT, and then GPT. So GPT-3, they have DAL-E, Retro, and so on. So you already learned the basic one, which is transformer. And today, let's look at the details about BERT and GPT. When we deal with the pre-trained model, there are some kind of naming convention. Name. So they want to put the name. It means every name has their own meaning. We will take a look. What does it mean, this one? Many deep learning models, including pre-trained, use cute names. Okay. So people say that they use the cute names. For example, Elmo. Have you heard about Elmo? Elmo is a character in one of the famous cartoon in USA. Okay. So it is one of the famous cartoon character. Okay. BERT, Albert, GPT. Okay. So this also, referring to some kind of character. So BERT, this is also a kind of character. Albert is different. This is maybe referring to the person name. So actually, the naming, they refer to an exact combination. For example, from the name, we can understand the model architecture. If they have the BERT, or if they have the word E, for example, it means they have the encoding or they have the encoder. Okay. So last week we already learned encoder and decoder. So if they have the word E, it means we have the encoder. So the model architecture, we can be referring to the E. And also we can look at the naming based on the training objective. So for the pre-train, usually we know the pre-training objective. For example, if this is to do the language modeling for the mass, today we will look at this one, mass language model prediction. And we can also look at the data. So some of the pre-trained model, for example, GPT, they use the Wikipedia and the Google Book Corpus. But some other pre-trained model, they have their own reference for creating the model. So let's look into the detail. So this is the character BERT. So actually this is the character of BERT. And BERT refers to this word. Bidirectional, refer B. E refer to the encoder. R represent the representations from transformer. So we already learned the transformer last week. It means that whenever we have the input, we will have a kind of structure. So this is our sentence. This is going to be so long. And in order to create the bird, actually there is a kind of rule. Yeah, later we will take a look. We call it CLS. Okay, and then we have the mask. The bird needs some mechanism, for example, randomly masking. And the randomly masking, it requires some percentage of the tokens to be randomized before we enter into bird. And after we enter into bird, then we will do the feed forward neural network. This is FFNN, feed forward neural network. And then we can do the possible classes prediction based on the probability, and we can predict what will be the best output for the masking. So this is the masking. So we are going to predict the mask section using BERT. In the terminology, we have bidirectional. Bidirectional. What does it mean by bidirectional? It means we have forward and we have backward. So we have forward and we have backward. That's why we call it bi. Bi-direction, it means two direction, forward and backward. So similar to bi-directional LSTM, it looks in both direction. If you do with the LSTM, okay, we have the bi-directional LSTM. So we go forward. After we go forward, we will do backward. It is to improve the model. After we go until the initial state again we do the forward until the weight is converts. Then we can use that model to predict what is the best output. So this is the bidirectional. About the encoder. So encoder means this kind of pre-trained model only use the encoders. If you understand the transformer, last week we learned the transformer. It contains encoder and decoder. But when we use the BERT, actually it is only using the transformer encoders, no decoders. So if you look at the development, later on we will also look at the details. But it is based only on the encoder. And then the development of BERT becomes Roberta. So because we are using still BERT, so it is a pre-trained model only with the encoder. Albert, it means this is also based on the encoder only. This still BERT, this is only based on the encoder. Deperta, this is only based on the encoder. Or long former, this is only based on the encoder. So if you look at some of the pre-model or the pre-trained model, we can distinguish the red color, it is based only on the encoder. And if you are using only decoder, we are also looking at the details later, the GPT. It is based on the decoder only, no encoder. So GPT-2, it is decoder. XLNet, it is decoder. GPT-J, OPT, Bloom, and so on. So the development rising until now, it is based only on the decoder. However, some of the model, they rely on encoder and decoder. For example, yeah, BART. Yeah, so I think we will also look at the pre-trained model BART in our code, in Python code. Pegasus T5. Okay, so they use encoder and decoder. The representation. The representation means for every of this model, they have their own representation. And we already learned the representation. It means this is the word embedding. What kind of word embedding models do you use? If it is context independent, if there is no context, then you can use the common word embedding. The common word embedding, for example, the word to fact, glove, past text. So this is the common word embedding. You can use it for any kind of text. But there might be some kind of context dependent word embedding. In the context dependent, there are two kind of method. First, you can use the RNN base, and the other is using the transform base. If you are using the RNN base, we can use the Elmo, we can use Cove. This is embedding models based on the RNN and the transformer base. Okay, so because we are using the BERT, so BERT is one of the model based on the context. Albert, Roberta, XLM, and so on. So this is the categorization of the word embedding models. BERT, it is a pre-trained model for the contextual word embedding. And this pre-trained model, actually the first task for this pre-training, it is for the mask LM. Mask. We will take a look on the detail about mask LM. It is the language model. So we are going to model the masking section on our sentences. And BERT is good for next sentence prediction. Okay. So the pre-training task, it was built for two kind of tasks. This is only for BERT. And the training data set for BERT, it was based on the book corpus. So in the public space, in the internet, there are some book corpus, and then it is freely available. So they use the free book corpus, and this book, they have a lot of text, and they use this text to build the pre-trained model or the BERT. And also they use the Wikipedia English. This is from the original BERT. There are about 2,500 million. So it means 2.5 billion words. They collected from the Wikipedia and they built BERT. And the training settings, they have the billion word corpus was not used to avoid using shuffled sentence in training. And yeah, the training with long contiguous context. So they have a lot of sentences and they try to find what is the context between this word and the other words. So they have the long contiguous context for BERT. That's why many of the current pre-trained model, yeah, they are also using BERT because they are reliable when the context is long. BERT with mass language model. We use the word must. What is in Korean? Kawang. So it means we are deleting one part. So we do not use one part from the sentences. And then we want to predict this part, or we call this masking. So for example, here we have the sentence. Okay. This sentence is, let's stick to improvisation in this skit. So this sentence, there is a starting CLS. CLS means the starting of the sentence. And we have the token. We have the token stick, we have the token two, we have the token improvisation in this skit. And then we will do the random masking. So for example, we are using this token. So the fifth token will be mask, or we want to remove it. And we put the other text as the input. After we have this input, we put it into the BERT, and we can get the output. Usually, BERT has the length of 512. After we have the output, so we do the modeling with the feed-forward neural network plus the softmax, and we can get the probability. So this is the probability. The highest probability in the BERT, you can get the highest probability. Let's say the highest probability is improvisation. Then this word will be used for this mask position. So this BERT will be trained many times, and after the prediction is highly correct, then this BERT can be used to do the prediction. So it is to use the output of the mask words position to predict the mask words. It is to predict this mask word in this position. And we can also do the sentence prediction. Sentence prediction means if there are two sentences are fed in at a time. So for example, this is sentence A and this is sentence B. So CLS, okay, it represents the first sentence or the starting point of the input. The starting input starts. And then we have SEP. SEP means the separator. It means this is the sentence number one. This is the sentence number two. In between those two sentences, there is a separator. So the separator can be dot. So when you finish one sentence, you usually finish with dot. And then after dot, we call this is the separator. We have the second sentence. We have the second sentence. And after the sentence finish, we have another separator. And so on. Now, the same with the previous one. In the sentence A, we are using one mask. Again, it is randomly chosen. And for the second sentence, we also have another mass. So we put those things into the bird. For example, this is a sentence. The man blah 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 to the store, blah 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 penguin, blah 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 are flightless birds. So if you look at this sentence, actually those two sentences are not related. The first sentence, it is about a man to the store. So maybe the man goes to the store. The other sentence is about penguin. Penguin are flightless birds. Okay. So this is about person, and this is about animal. Actually, this is not correlated. And we are going to put on the bird and let the bird predict using again the FFNN and softmax. We can predict the likelihood that the sentence B belongs after the sentence A. It means we want to predict if the second sentence of input truly follows the first one or not. Then we will get the probability. Okay, is next. If the sentence is in the next of the sentence A, if it is true, then what is the probability? If it is not true, what is the probability? So it is true or false. Because the probability is highly on the false section, 99%, then we can say that this is not the correct next sentence. If it is not the correct next sentence, then we need to change with the other sentence. So the sentence can be fluently matched with the sentence A. So this is the two tasks for bird. So this is the idea of the embedding. In the bird model, you will have the CSTLS, this one. And then this is the word. You will need to determine where is the mass. And this is the separator. And then this is another word. This is another separator. For each of this one, you will have the token embedding. And then you have the segment embedding. And you will have the position embedding. So the token embedding, you already learned. We can use the one-hot encoding. We can use the back of words. The segment embedding, we can have another kind of embedding for this one. Position embedding, we can use sinus, cosinus based on our previous lecture. Then the combination of this one, x plus xa plus x1, then this will be the new embedding for the input. This is only the performance. Okay. In 2018, this paper, they tried to show the performance. This is a comparison with the pre-OpenAI. At the time, the OpenAI has not been so popular. And they also compare with the by LSTM with the Elmo and the attention. And they compare with the OpenAI GPT. At the time, the GPT version 1. And we can see the bird base and the bird plots for the multiple natural language inference. The result is the highest among the existing method. So it was obtained from this benchmark report. So you can look at the details later. Okay, this is just a comparison. Okay, so this is the MNILI, QQP, QNLI, SST, COLA, STS, MRPC, and RPE. So it is referring to this one. So what is MNNI, QQP, UNLI, SST, COLA, SPS, MRPC, and RP. I will not discuss on the details. So if you have interest, you can look at this metric for maybe for your project or maybe for your future risks. Okay, I will stop here. I will continue the remaining section tomorrow. Okay. Any questions?